Okay, we're looking at lesson 2 today, talking about division properties of exponents, which follows what we just did yesterday, which was multiplication, right? So, on yesterday's, when it was multiplication, what did we do to our exponents? We added them together, right? So, what do you think we're going to do when it's division? We're going to subtract, okay? So, we divide like bases. By keeping the base.
Is it literally the same thing, but you just subtract the exponents and divide them?
It's, yeah. I mean, essentially. And subtract your exponents. Now, the one thing I'm going to tell you, which I'm going to walk through this with you. Remember yesterday, like regular numbers didn't have a special rule, right? We just multiplied them. Or if it was 3 to the third power, we took 3 to the third power. So same idea today, a regular number, we're going to divide or just simplify the fraction, okay? Which we'll see some examples of that as I go through this today, okay? So example 1, we're going to start with an easy one, m to the 4th over p squared, m to the 2nd over p. Now, we talked about yesterday, anytime I have a variable without an exponent, what exponent would you want to write in? 1. So I'm going to give this one p to the first power. And then all we're going to do is subtract exponents for like bases. So what's the first base that we see? M. And what exponent are we going to be left with? 2. And for p?
1.
Or just p, right? Now, is it wrong to put 1? Not 100%. Should you put 1? No, because it's understood that the 1 is there. So really, anytime you're left with 1, just put the variable and be done with it. Fair enough?
Yeah.
Okay. All right. Do I need to put exponents with any of these? No, right? They already all have an exponent.
Wait,
So,
I have a question.
Yep.
Like the exponents, if you're subtracting them, you put the what you get just on the first variable.
Like where at are you asking?
Why is
Kind
there
of?
nothing on p?
On p? Because we got 1. Because 2 minus 1 was 1, and it's just understood that the exponent is 1 there. So if it's anything other than 1, we will write it. If it's 1...
Oh, okay. You're going that way. Okay,
Oh, yeah. Sorry.
Okay,
Yes.
okay.
2 minus 1 to get our exponent here.
Okay.
Yes. Did you think we were going across this way?
Yeah.
So, right. Only you're subtracting things that have the same base, right? So both of these have m, so we subtract 4 minus 2. Okay. So here, right, we look at both things that have c, and what are we subtracting for our exponent?
4 and 2.
4 minus 2. So we get c to what power?
2.
The second. What about d?
D. Just D or
D to the 0 power.
Because if you don't put anything with it, it'd be 1.
Yeah, if I put d and then don't put anything with it, it'd be 1, right? So d to the 0, which we're going to talk about it, and then f to the 0. Now, Lath, actually, anyone with a calculator, I want you to type 3 to the 0 power. So 3, arrow above, to the 0 power, what does it tell you? 1, right? So, now type 5 to the 0 power. Okay, so anything to the 0 power is equal to what? 1. You might want to write that out to the side. Okay, so essentially, these two that have d to the 0 and f to the 0, can I just get rid of those? Because that's really like saying c squared times 1 times 1. Well, does multiplying by 1 change c squared? No. So really my answer here is just c squared. Now, can I give you guys a little hint to help us with this? What do you notice about these two with F and with D? They're exactly the same. What happens when we're dividing two things that are exactly the same? Yeah, they cancel out because 5 divided by 5 is 1, right? Same thing here. F to the third divided by F to the third gives you 1. So really, you could just cancel those out. You don't have to give me D to the 0, F to the 0 every time. If you want to, that's fine. But you will never leave something to the 0 power, okay? Make sense? All right. Now, since we're talking about 0 power, I want to show you this real quick. You don't have to write this example down, but I want you to have at least seen it. If I have like this huge long thing, 3x squared, y cubed, z to the fourth over 5x, y squared, z squared, and that whole thing is to the 0 power, what's my answer here? 1. Okay? Because we just talked about anything to the 0 power is equal to 1. So if this whole entire thing is in parentheses, everything inside is going to give you 1. Okay? Now, just for future reference sake, what if only the top part was in parentheses to the 0 power? Then the top part would turn into what number? 1. And it would still be over this 5x y squared z squared, okay? But anything to the 0 power automatically turns to 1, which is simple for you all, yes? Okay? All right, 3 more examples, and I'll be done. Are we feeling okay with it so far? No. Hey. Over Lath? He said your head's in his way. He said boo. Sorry about you. Okay. Any thoughts here?
Would it be 9 divided by 3?
Perfect. Which is what? 3, right? So in this case, now here's where we have to be. I'm going to show you an opposite example in just a second. Is 9 divisible by 3? Yes. So we divide, right? 9 divided by 3 gives us 3. What variable do we write after it? D. Is D going to get an exponent? 1. So am I writing 1? No. So just 3D is my answer. Okay?
So it doesn't have any special rules for the numbers, you just divide them?
Correct. Now, the only thing I'm going to tell you that's special is going to be like this problem, which it's really not special. It's just this is the mistake I see most often. Is 12 divisible by 48?
No.
No, right? But can you simplify 12 over 48? Yes.
Yeah.
What is it?
I don't even know.
What are 12 and 48 both divisible by? 6, but also bigger number than 6. 12, right? What's 12 divided by 12? 1. What's 48 divided by 12? 4. So it gives us 1/4. Now, you guys remember your calculator can help you with this, correct? If you type 12 fraction 48, it will simplify that for you if you're having troubles with it. I want us to try it before, but I would always double check that, okay? So I've simplified the number part. Now what do I do with this? 5 minus 1 would give me x to the 4th and then y to the 2nd. No matter what, you guys, when you subtract, if you have a fraction, when you subtract those, they automatically go to the top, okay? You with me? So really, your final answer would just be x to the 4th y squared over 4. Now, if you left that 1 on top, okay. But again, is this 1 right here necessary? No. Okay? So does everyone understand the difference between 4 and 5? You're either just dividing the numbers or simplifying the fraction. Okay? Yes? Okay, last one. This one, technically, is really what we did yesterday. 3n p to the 3rd over 7q squared. And the whole thing is going to be squared again. Okay? Now, we talked about this yesterday. We just didn't have a fraction, right? So what am I going to do first with the number 3?
Multiply by 2.
Multiply it by 2
No, you go to the second power.
to the second power, right? So 3 squared, what's 3 times 3? 9. Okay. Then what exponent does n have right here? A 1. And what am I doing with these two numbers? It's a power to another power, Kaylin. Yeah. Multiply. So I get n to the second and p to the sixth. Then I'm doing the same idea on the bottom. 7 gets squared. What's 7 squared? 49. And then what am I doing with my exponents? Q to the fourth. Now,
And then do you have to
can you simplify 9 over 49? I asked this question to my other class. What is 9 divisible by? 3 and itself, right? 3 and 9. Do you guys know how to determine if 49 is divisible by 3 and 9?
put it in a calculator?
Well, true. Let's say you don't have one. All you do is add the two numbers. What's 9 plus 4?
13.
Okay. Is 13 divisible by 3? No. Is 13 divisible by 9? Also no. So neither is 49. Okay. It's an easy way to see if something's divisible by 3 or 9. Now, can I subtract either of these with 4? Who said no? Haven? Why? Good. They're not the same base, right? N, P, and Q, none of those have the same base, so you cannot do anything with it. So that's your answer. Okay? All right? Okay, today we're going to do just a few problems out of our book. So we're on page, I think, 341. Look that up. Yes.